Okay, here we are for our unit circle project, and now we're moving on to the multiples of 60-degree angles. Okay, so I have drawn a special triangle here that again has a hypotenuse that is equal to the radius of the unit circle. So we're calling it 1 unit because that's what the radius of a unit circle is. So 1 unit. And this triangle is 60 degrees right here. Okay, so we're talking about multiples of 60 degrees in this video. So this is 60 degrees, 90 degrees in the right angle, which means we have 30 degrees left up here. All right, so let's take a closer look at this special triangle. I just recreated one here. And we are calling this side 1 unit because that is our hypotenuse. It's also on our unit circle, the radius of the unit circle. All right, so we know that theta is equal to 60 degrees, and we want to figure out how long is this side and how long is this side. I'm calling this one x because if we think about where this special triangle is on this unit circle, we can see that the length along the bottom of the triangle will be the distance on the x-axis, so therefore will be the x-coordinate of this point on our circle. And this distance here, I'm calling it y because on our axes that would be the y direction, so the y-coordinate. Okay, so here we can use right-angle trigonometry. So remembering SOHCAHTOA again, right-angle trigonometry to determine the lengths of these other two sides. So let's start with our x. If we use cosine of theta is equal to adjacent over hypotenuse and fill in what we know. We know that theta is 60 degrees. We know the adjacent, we're calling it x, and the hypotenuse is equal to 1. Okay, so when we do this, x will be equal to the cosine of 60 degrees. Let's poke that in a calculator and see what we get. Where's my calculator? Here it is. So we need to be in degree mode. That's what we're working in right now. So if you're not in degree mode, change to degree mode. Or you could keep it in radians as long as you use what angle here? That would be pi over 3 radians. Okay, so you could do that if you would rather. Or pi over 3 radians. I guess I don't need to write it there. Okay, so cosine of 60 degrees or pi over 3 radians is 0.5. Okay, 0.5. Okay, so 1/2. Okay, so x, that x coordinate, the x distance, sorry about my arm in the video there, is 1/2. All right, let's figure out what the other value is. So sine of theta is opposite over hypotenuse. The angle we're dealing with is still the one in here in the middle of the circle when this triangle is put on the unit circle, so 60 degrees. Opposite, we're calling y. Hypotenuse is still 1, so y is equal to the sine of 60. Let's poke that in our calculator, see what we get. Sine of 60 degrees, or pi over 3 if you are in radian mode. 0.8660, and there's some more digits there, but keeping 4 decimal places is the right amount to be significant enough. Now, I want to talk about what that value is in an exact number. If you look at root 3 over 2, poke this into your calculator, that's actually approximately equal to this same number. Okay, so we're going to use this value because it's exact. So this distance here is root 3 over 2. All right, now let's look at our unit circle and apply this information to ordered pairs that exist at the 60 degree places. All right, just going to tidy this up a bit. Get rid of this from the background. All right. So we have, let's use green this time. So green for our 60-degree angles. There's our first one, 60 degrees. Okay, so I'm draw that with my ruler. $60 degrees, where are you here? Okay. 60 degrees up here. And that will be flipped over here as well. So another 60. And another 60 would be down here to 180. Another 60 would be flipped this way. So we'll come down here. Another 60 would flip this way and come down to here. All right, so we have these places on our unit circle. So if we start at our initial ray and go up to here, that's 60 degrees. Start at the initial ray and go to the next green, that's 120. Start at our initial ray, add 60 more, that's 180. Initial ray, 60 more, 240 degrees. Initial ray, 60 more, brings us to the next green, which is 300 degrees. And then from the initial ray all the way around 360 degrees. Okay, so we could mark those on, but we're going to put the ordered pairs on first. So where's that little special triangle again? Here we can see the x distance is the 1/2 and the y distance is the √3/2. So that is our ordered pair up here. So 1/2 √3/2. Then when we look at the symmetry of this, reflect this triangle in the y-axis, bring it over here, we can see this is our 1/2, but it's in the negative x direction. So the x coordinate is negative 1/2. Still the same distance up, so √3/2. Flip it down. Again, still the same distance, 1/2, but in the negative direction on the axes. And still the same distance, √3/2, but now it's in the negative direction. So negative √3/2. Flip it the last way around here. All right, so same x coordinate, 1/2, and in the positive direction, √3/2 in the negative direction for the y coordinate. All right, now we just have to add our angles on. So remember, each angle is measured from the initial ray up to where that terminal ray is. Okay, so first one, 60 degrees or pi/3. Next one, 120 degrees or 2pi/3. Next one would be the 180 or pi. Next one would be, add 60 more, 240 degrees or pi/3, 2pi/3, 3pi/3, 4pi/3. Next one will be 5pi/3 or add 60 degrees, so 300. And the next one, 6pi/3, better written as 2pi or 360. Okay, there we have it. The special angles for the 60-degree multiples. Now, what this means then is you can now determine the cosine of 60 degrees. So if we look at our unit circle, terminal ray, find 60 degrees up here. The cosine is represented by the x coordinate. So that's actually equal to 1/2. We could find the sine of 4pi/3 from using our unit circle and knowing it. Terminal ray, initial ray, all the array around to 4pi/3. The sine is represented by the y coordinate. So the y coordinate is negative root 3 over 2. And if you poke this in your calculator, if you're in radian mode and poke this in your calculator, sine 4 pi over 3, you'll actually get the answer negative 0.8660, which is equal to negative root 3 over 2. And on and on and on. This is what the unit circle is good for. Have fun with it.